Hello and welcome back to differential equations.
We're doing great.
Yes, this is a review for exam 3.
Exam 2. Yeah. We're live.
Oh,
Yeah.
exam 2. Yeah, thou shalt fix that in the title then.
Restart the stream.
That's okay. There we go. That's fixed. All right. Hello and welcome back to differential equations. We are back from the Thanksgiving break and it's time for exam 2 review. You had a question? Yes. So we first have the power series one, you said?
Y prime equals x squared times y.
There's no y double prime. This is y.
That's it? All right. So, use power series to solve this differential equation. What we are going to do is move everything to the left. And then we will assume that y is equal to some power series. I'm going to use n's. There we go. And the derivative of that would be 1 to infinity n cn x to the n minus 1. And we are going to plug everything into our problem here. So we have summation 1 to infinity n cn x to the n minus 1 minus x squared summation 0 to infinity cn x to the n equals to 0. Now we are going to take a look why this x has to go in. So 1 to infinity n cn x to the n minus 1 minus summation 0 to infinity cn x to the n plus 2 equal to 0. So now we have issues because counters don't match and exponents don't match. And we have to make all of that match. So we can shift the counter on the first one by subtracting 1 to both sides. So this one shifts to 0 to infinity n plus 1 cn plus 1 x to the n. Now the second one has to shift because I need this to be n. So yeah, we have to do minus 2, which is going to put this into a negative. Yeah. So, what now?
Can't you,
So, instead of working on that term over there to fix that exponent, we can bump the first one 2 exponents up, right? So we bump the first 2 exponents up, which means that each n now needs to be k plus 2. Sorry. Now, is this going to help us? This is n equal to 0.
that's k plus 2.
No, n needs to be k plus 2. I had it right. N needs to be k plus 2. So this one is going to go backwards here to negative 2, right? That's bad. Yeah, so we have to transform this side then. Okay, that's a little bit convoluted question. N plus 2 equals to k, because this is n equal to. And if I add plus 2 on both sides, that works. Nice. All right. So n equals to 0, infinity, n plus 1, Cn plus 1, x to the n, minus summation. And now I'm replacing, so if I add 2 to both sides over here, I have n plus 2, which is k, and that's now at 2, and there is infinity over here. And then this is going to be c of k minus 2, and x to the k.
You got me lost on the n plus 2 equals k, and then you said n plus 2 equals 0 plus 2.
Cn.
Right, so when do we say that's a minus?
So what's n?
K minus 2, right?
From here, n is equal to k minus 2, right?
Right. But how did you say that the n underneath the summation? You have n equals 0, but you have a plus 2 and plus 2?
Yeah, plus 2 on both sides. So n plus 2 is k, and
Right.
0 plus 2 is 2.
Oh, okay, gotcha.
Right?
All right, so then the n's are the k minus 2 now.
So now what I have is the summation n goes from 0 to infinity of n plus 1, Cn plus 1, x to the n, and now rename these to n's. Yeah.
You like those equal signs.
Yeah, I don't hit the shift quick enough. 2. And then, no, now it's n. Cn minus 2, x to the n equal to 0. Now, we got the exponents to match. I need now to do some peeling, because they don't match on the counter, but they do match on the exponent. So we peel n equals 0 in this case. So we have a 0th term, which is going to be just C1 plus, now peel n equals to 1, that's 2C2 x, and leave the rest, plus summation, and now we start at 2 to infinity, n plus 1, Cn plus 1, x to the n, minus summation 2 to infinity, Cn minus 2, x to the n equal to 0.
What do you do with the peeled off? Do they just
We're going to deal with those as well. They don't sit there. Everything over here is equal to 0. So this part needs to be equal to 0, and this part needs to be equal to 0, so it all equals to 0. So peeled off terms, they're going to play a role as well. So now, C1 plus 2C2x plus series 2 to infinity of n plus 1, Cn plus 1, minus Cn minus 2, x to the n equal to 0. So now, this part needs to be equal to 0, which gives us that C1 plus 2C2x equal to 0. And we have this part over here to equal to 0. Since x to the n is different than 0, we don't want just a... why am I using... Oh, that's all good. All right, good. So now we have the recursion equation over here, n plus 1, Cn plus 1, minus Cn minus 2 equal to 0. Now, I hope you see that the counter starts at 2. So the first term we are going to calculate is n equals to 2. Is that bueno, everyone? So the first term on a series is 2, so n equals 2, and that's the first one we are computing. Now, when n is equal to 2, we get 3C3 minus C0 equals to 0. Actually, I could, let me just massage this a little bit to get Cn plus 1 is equal to Cn minus 2 divided by n plus 1. Like that will be, because I remember you guys were really vocal about that last time.
But we solved it differently and have we have Cn plus 3, we will Cn plus 3, and it starts at 0. Will we get the same answer? Or?
We should. N equals to 2. So now, C3. So what's C3 equal to?
0.
C3 is equal to C0.
Oh yeah, the count was 2, so it would be 3CN3. Would be a C3. I think.
It is C3 because n is
No,
2.
for the recursion, wouldn't it be?
We are starting at 2
Oh yeah.
because we peeled off 0 and 1.
Yeah, okay, yeah. Now I'm seeing it. Yeah, okay.
So C3 is the same as C0. N equals to 3. So that's a C4. And C4 is equal to what?
1 over 4.
C1 over
Wait, well, how is C3 equal to C0? Because 2 minus
N equals
2 is
2.
0. But 2 plus 1.
Oh, over 3. Yeah, please pay attention. N equals to 4 is a C5, and that's going to be C6 over, and we have, over here we have a 5. That's what I said.
Please pay attention.
What happened?
How do we know what n values to walk to?
Looks like they're just going in order 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yes.
You can go as far as you want.
You are so really deep.
Just do 2 terms, right? And we're done. All right, great. So we are starting at n equals to 2 because of the... We started at n equals to 2 because the series starts at 2.
So the one example that you did, the series started at 2, but then you started at n equals 0. And this is what confused me.
I'll take a look at that later. But as you can see, n equals to 2 on this one.
How
Yeah,
did you...
and then like in the example,
Can you go back up and... How did you get to C1 plus 2 C2x? And how do you...
When you peel off the terms from here, we need to peel 2 terms, so it's n equals to 2.
Right, okay.
So when I plug in n equals 0, that's 1 times C0 times x to the 0. So 1 times C0 times 1 is C1. And then plus, the next term is 1, so 2 C2 x to the 1, which is x.
We don't add that... So if it's 2, because it has n plus 1, we don't worry about that plus 1.
What plus 1?
So like...
This plus 1?
Yeah.
Of course you worry about it. Because when it's equal to 1, 1 plus 1 is 2, which is this one. When it's 0 plus 1 is 0, is 1.
Ah, okay.
Exactly. Now, if everything is in terms of... now, where is my C2? Here. So...
are they separate?
Yeah, you do the coefficients, so it'd be C1 equals 0 and C2 equals 0.
What?
I think. This is what I learned doing the homeworks.
Because it's very separate. Oh, yeah.
Mm-hmm.
So when you do C1 equals 0, equals 0, that's 0.
Okay.
Is that right?
I thought you had to add a 1 or something.
So what happens then? Guys, shh, 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 shh.
C1 equals 0, C2 equals 0, and then put it all into the mixed. And then
And that's going to zero out all of your coefficients.
Not all of them. No, C0.
We don't have C0 in this one. We only have C1 and C2.
Well, because you split them out. Is that what you're supposed to do? Well, I got the right answer.
But you said that they didn't match your...
My answer is the recursion. Yeah. I think I got the right answer, but yeah, I got the recursion.
But that's okay. You can have different recursion.
No, my answer, my X value is the X value. Mine's off, and then I still know why. Like, I got all of that.
You could just copy it off over theirs.
No, but we can't do that on the exam.
Well, you two can telepathically get it.
Would C1 and C2 be zero?
Explain.
Is that right?
In my opinion, yes.
Yeah.
What I learned from the treacherous homework.
Treacherous homework. So, all right. So this sum over here needs to be equal to 0. Now, because the sum needs to be equal to 0 and x is non-zero, remember this part here where we said x is non-zero, so the recursion is equal to 0. Since x is non-zero number, right, then this thing has to be 0, which zeroes out that term. So we are getting here that C1 is equal to 0 and C2 is equal to 0 because of the requirement that this whole sum has to be 0. So one more time, the sum has to be equal to 0 because we are equaling it to 0 here. So the sum has to be 0 and the series, well, actually one step below, I actually have it. So this part has to be 0 and the other part has to be 0. And the only way for the non-zero x for this term to be equal to 0 is to have C1 equal to 0, C2 equal to 0. But also, if x is non-zero, we can have that these two terms are equal to each other, right? Which is another case that we have to consider. So now, when C1 is equal to 0 and C2 is equal to 0, so that gives us that this is equal to 0 and this is equal to 0, because C1 and C2 are zeros. Now, C2, so this is going to be, now you see that there are a lot more terms that you need to write in order to get this all the way to the end. But so C3 survives and C0 survives. But now C6 is in terms of C3, so that's going to be C0 over 18, and that one survives. So C6 survives, but C7 is doomed because C4 is 0, so that one is 0. N equals to 7 is C8, which is C5 over 8, and that one is equal to 0 because C5 was 0. Now n equals to 8 is C9, which is C6 over 9. Now C6 survived, so that's C0, and you know what, I'm going to actually write this as 3 times 6 times, and now 9. Maybe it's better if I write it as 3 times 6, sorry. I know. So we have all of these coefficients that worked out, and you guys, I hope you guys got the same coefficients to work out. So n equals to 9 is C10, which is C7 over 10, and C7 was 0, so that one goes away. n equals to 10. C11 is C8 over 11, which also goes to 0. And the last term I'm going to write is n equals 11, which is C12 is equal to C9 over 12. And that one survives, so C0 over 3 times 6 times 9 times 12. So what is the solution that I should write? Yeah. So the solution is, so what survived? C0 survived, right? So we have y of x is equal to, and we have C0 which survived, which is 1. And then plus, the next one is 1 over 3 plus 1 over 3 times 6. Is it 1 over 3 first? Yeah, C0, right, over 3. Oh, I forgot x's. Sheesh. I forgot x's. Now, hold on, we have to find what it is. So you see that n is equal to 2 on the 1/3. N is equal to 2. Then you go back and you make sure that that's to the n, and it is. So you plug in 2. So the first one is x squared. Why is x cubed?
All the coefficients are listed now, C11 and C12 correspond to that x, so that n value. So
Yeah, this is x to the 11.
No, that's C11 is x to 11. That n equals 11 is for that specific series.
Hold on. Look.
Is great. Now that's when you peel off and for that specific series.
Yeah.
You wrote the solution there, which is Cn x to the n, right? That's your solution. You already said that in the very beginning. The solution is Cn x n.
Yeah, right here.
But that's not the same. That's not the same.
Yeah,
for
so
the
like
circuit.
C3 means your x has to be to the third power.
Right. Because the n
So
is still the
there's
same.
no,
You
but
didn't
it
change
just
the
so
n.
happens that's when n is 0.
What's happening right now?
Wait, hold on, everyone.
All right.
This n equals to 2 corresponds to the series Cn x to the n.
No.
From 0 to infinity. Hold on.
That n equals 2 corresponds.
So that's n equals 2 produces C3. Oh, the 3, that's what you're talking about. 3 goes here, so cube goes here.
And also it would be every 3 exponents. So if it was x to the 0, then the next one would have to be x to the 3.
Full refund after that.
Full refund on the... There we go.
Bullshit.
Oh, Jesus.
Now, the first one is x to the 0, which is 1. So now, if you want to put this in, can we compress this?
Yeah. You have to use triple factorial. Yeah.
Yeah, this is like where I get to when I stop.
You can't write this as a separate.
Triple factorials. Actually, you can, can't you just define this? Yeah, because it's a 3,
What about this?
and then 3 is 6. So you can write this as 3 times.
That's only for a finite number of terms. You don't write it in series.
So 3, and then 3 and 3, it takes you 1 times 2. So yeah, you will have to do the double factorial or triple, whatever. But look, this is going to be 1 over 3 times 1 over 1. The next one is 1 over 3 times 1 over 1, and then another 3 over here to give you 1 times 2. Yep. And then 1 over 3 times 3 times 3 to give you 1 times 2 times 3. Yeah, this one is tricky to put together, but it can be. I mean, you can do it if you think about it a little bit.
Oh, wouldn't it just be?
So this one is going to be 3 to the n, 1 over 3 to the n, because it goes 3. Well, 3 to the 0 for the first one, and then 3 to the 1, and then 3 times 3, so that's 3 squared, and 3 cubed, so that matches with the 1 over 3 marching that way, and then times the n factorial. And the exponent is a 3n,
This got haywire real
starting at 0. So x 3n, and we have c0 in front, and then a summation that starts from 0 to infinity. So it can be compressed into series, dare I say easily, c0, 3 to the n, n factorial,
So
x to the 3n.
Your answer?
I did not put it into summation, but I thought, do we have to get?
No, you don't have to put it back in summation. It's just interesting when you can to show off the mental superiority.
I don't have
Well, we're not that interested, right?
Yeah.
That's fine.
So, n factorial.
Yeah, you don't get off the plane unless you know your n factorial. What's an n factorial? Alright, you stay here.
Just keep flying.
No, in order to access the parachute, you need to access
No,
the
no,
passport.
no.
and
Just aim for the runway lights.
Yeah.
runway lights.
You can count up the n factorials and the runway lights. You're good.
Okay. Next question. What was the question?
Yeah, go
How you
circuits.
could possibly see those, the I, the C, the R.
Okay.
I see R.
How would you see?
Or LC, that's it. LC.
Capacitors.
Pick up the values.
Oh, so you can put the value?
Well, it's no different than what our vibration, like the
Exactly.
problems are.
We have Laplace. We did the power series. We got the electrical, convolution. How many more problems can Laplace do? 6.
I still want to do another undetermined coefficient.
Yeah, can we do that? And then like a Blonsky, whatever it's called.
I mean, I was watching Thanksgiving review, waiting to do an undetermined coefficient, and it didn't show up.
Well, maybe that's
One of them is just a formula based. One of them is just a formula. Then again, I do need to know this too.
Yay, Li double prime plus Ri double prime.
So, who can tell me what C is? Capacitance measured in farad.
Henry's.
What is R?
What?
Resistance measured in ohms. So, guys, when you are dealing with the word problem, look for the units to tell you which value goes where. Don't just, you know, plug the stuff where it belongs.
L1
2.7.
No, in the book. I think that's like 4.
So in a circuit,
What page, Professor?
this is problem 4 on 179.
179.
So in a circuit,
Thank you.
we have the L equal to 2, R equals to 40, so 2 Henrys, 40 ohms, and ET given to be 100 e to the negative 10 t, and I 0 equals 0.
That's a condition, the I 0 equals.
Yep. So now we plug everything in.
2I double prime.
So what's happening with our C term? There's no C term, right? So we have 2I double prime plus 40 I prime is equal to, and now we need the derivative of E to plug in. So that's negative 1000 E negative 10t. So generally you forget to differentiate that, and that's where it goes bad.
You do need? Okay. Is it because it's E prime, that's why?
Yeah.
Alright.
So now we get to solve this. What should we do? We do the homogeneous problem over here with 2r squared plus 40r equal to 0. Kick out 2, you get, sorry, kick out 2r. R is r plus 20 equal to 0. So r equal to 0 and r equal to negative 20. So we get that the current I in time is going to be what? C1 e to the 0, so that's just C1 plus
C1 e to the negative
C2
C2 e to the negative 22.
e to the negative 20t. Now that is only the first half of the problem.
We have to differentiate that.
Would you be able to move the E over?
No, because it's not like terms with I, right? The left, I mean, these are all, the equation over here says that the voltage drop plus the voltage drop plus the voltage drop equals all of the voltage available.
What is it that they're asking for that we're solving?
We're solving for current, right?
Current?
Yeah.
That would be the 1 over C? Or
No,
just
that's
the C?
I.
No, we're looking for I.
I is current, which is amps.
Okay.
So I of t. It's I of t in a certain amount.
That's fine. Move over this one over.
Yeah. And so you still don't get it.
All right, now what?
Once you differentiate it,
We have to calculate particular solution. What is the way we calculate particular solution?
right, so two derivatives.
Very good. So we have our y particular, right? So how many, what do I have? I have negative 1000 e to the negative 10t.
Right.
And then I take
Yt prime.
prime, which is 10,000 e to the negative 10t.
Wouldn't this still technically be f(x) and y(p) is the formula behind it?
Yeah. It's a solution. It's IP or whatever. Minus 100k e to the negative 10t.
Hey, then we put those back in.
So what is the general form of this?
A e to the negative.
A e to the negative 10t. So that's the general form. And then we take two derivatives of those. So negative 10a e to the negative 10t and the double prime would be 100 AE negative 10t. So now we plug that into our original formula. So 2 times 100 AE negative 10t plus 40.
Where did you get the negative 10 AE and then the 100?
I prime. So negative 10 AE negative 10t. And then that needs to be equal to negative 1000 E negative 10t.
What you end up doing for IP equals AE to the negative 10t?
Well, we see that only coefficients change.
Right.
So the pattern is saying that you should keep this e to the negative 10t and just have some kind of undetermined coefficient right here.
Ah, so you just basically made them up?
So now, when you have that, you differentiate twice, plug in into differential equation, and now just work this out. So it's 200 AE negative 10t minus 400 AE negative 10t equals to negative 1000 E negative 10t. So this is negative 200 AE negative 10t equals negative 1000 E negative 10t. These die, and you have negative 200, so A is equal to negative 1000 divided by negative 200, which gives us 5. So all this work to get that A is 5, and we have that I in time is C0 plus C1E to the negative 20 t, and then plus the particular, which is 5e to the negative 10 t. And now we have initial condition of I0 equals 0. So we can calculate
That wasn't that bad. That was pretty good.
I0 equals 0. So now 0 is equal to C0 plus C1 and then plus, when that's 0, is 5. So we can, from here, we can calculate that C0 is equal to negative C1 minus 5. And then we can plug that in and get negative C1 minus 5 plus C1e negative 20t plus 5e negative 10t.
I'm looking at partial credit for this one, but it's okay.
Hey, at least you have your goal set on something.
That's like settling for the partial eclipse. It's just, what the fuck?
You gotta know your limitations.
C totality, damn
You gotta know your limitations in life, dog. Wait till you get there.
I of t, so we can kick out C1, and we are left with e to the negative 20t minus 1, and then you can kick out 5, and you are left with e to the negative 10t plus 1. No, minus 1. Or minus 5 over there.
But you can get I prime.
You don't have that second.
I don't have the second condition.
But you can say that I prime of t is equal to 2t over L. Like that's what the book did.
Wait, what was? The second condition you said?
Can I show you? Because I was just doing this.
I forgot about that condition.
Because if you set these two equal to each other and then integrate, you get that. Because that's what I did in the book. That's
Wait,
what
we
the book
didn't.
told me to do.
Why didn't we do anything with C2?
Hold on. So, oh, I used C1 and C2 and then I used C0 and,
Yeah,
oh.
C1. That's what was confusing.
Yeah, this is supposed to be 1,
Oh.
and then 2,
It's not just me, then.
and then 1, and then 2, and then 1, and then 2. Okay, so I'm going to erase this then.
Where was this?
No, you didn't miss it. Yeah,
So to find the second condition, I forgot about that.
It was C0.
no, there's no C0 either. It's a C1 and a C2.
Oh, okay. What?
E of t divided by L, which is E of 0. So I prime of 0 is equal to E of 0. What is the E? E was given as 100, so that's 100, and then divided by 2, so 50. Is it E of 0?
I believe so. Yes, E of 0, I believe, is 50.
E of 0 is 100,
Or 100, I mean.
divided by 2,
Yep.
so it's 50. Good.
Yeah,
Now we... So now, I prime of t is negative 20 C2 e to the negative 20t minus 50 e to the negative 10t. And when we plug in condition,
do we have conditions for this?
yeah, right here, 50.
Oh, okay.
So 50 is equal to negative 20 C2 minus, is this 50? And then negative 50 goes to the other side, becomes 100. Is equal to negative 20 C2. So C2 is negative 5, right?
Yes.
So if C2 is negative 5,
And then
that C1 becomes 0.
Hold on. No. C2 becomes 10. Or C1 is 10, isn't it?
No.
yeah, negative 5.
C1 is negative negative 5 minus 5, which is 5 minus 5, which is 0. So C1 is 0.
Just leave that real quick for a second.
Yep. So C1 is 0, gone. C2 is negative 5. Negative 20, there we go.
Yeah, the C2 is 0.
And there it is.
So I prime of t is 50.
If I pick the problem, I'll pick something nice.
You'll pick something where you'll give us the initial condition.
Condition, yes.
For the regular limits.
Yes.
So that's the I prime because that minus 22 minus 15.
What happened?
Over there.
Oh, that's all you wrote? One line. All right. So, guys, I completely forgot about this formula, to be honest with you. So what we're going to do is, if I'm giving you a circuit problem, you will have all the initial conditions, so you don't have to learn. This belongs to electrical engineering and physics, right? More specific. So I'll give you the initial condition, this one and this one, so you don't have to compute, right, stuff in between, if you have a circuit problem. All right?
Sounds good.
Any other questions, concerns for the exam?
Was that number 4 that we just did on page 1?
Yes.
Can we have a list of all the formulas we need to know?
List of all the formulas that you need to know.
Like the Roskian one?
Well,
That's the only one I do know.
So
So
you're not
awesome.
helping right now.
Yeah, I know.
all right. So
I always make things worse. It's my job.
list of procedures or formulas? So we start by, you still have to know from chapter 2, right, the coefficients, constant coefficients, where you get the characteristic equation with R's, right?
Yeah.
Then you need to know undetermined coefficients, var of parameters, Wronskian to check independence of solutions, and then mx double prime plus c x prime plus, anyone? Very good. Equals to, and this is now the change. You have some forcing term. So this was together with the circuits.
Yes.
Because it's the same type of a question. We did this part in early chapter 2 on exam 1 when it was equal to 0.
Yep.
Now for the second part, we are equaling that to f of x, and you are hitting this with the undetermined coefficients or something else. Oh my God, come on, stop this.
But we just got to remember we have to...
Now you have Li double prime plus Ri prime plus 1 over Ci equals to E prime of t, right, from circuits. So those are the formulas that you need to know, and that ends chapter 2. Then we are moving to chapter 3. The power series, you need to know to assume the power series Cn x to the n from 0 to infinity. Then y prime shifts by 1, which is n Cn x to the n minus 1. And the y double prime shifts by 2 for n minus 1, Cn xn minus 2. And then, you know, good luck with the rest.
Is that partial credit if we get that far?
Yes. You get 1 out of 10 points. Good.
Hey, to start.
So chapter 4 with the Laplace, you must know the formula for Laplace transform. So Laplace transform of a function of t is given as the integral, anyone? 0 to infinity st times f of t dt. Yeah, it's trying. You can see over here this little icon shows when it's trying to sync, and as soon as I see a little green thing over there, I know something is going to disappear. There it is. See a little, and it went away. So that's when it's syncing to cloud, and then whatever is not synced, it gets canned. All right. So you have to know the Laplace, because one of the Laplace questions you will have to do by hand. Then you need to know Laplace of y prime. You need to know that's not given. Laplace of y double prime, right, to solve those. So, you know, the s squared f of s minus s times y minus y prime for conditions. So you need to know those. And now, what happened? The derivative? Well, that's the derivative form. Okay, who can tell me? The first derivative was s f of s minus y of 0, right? S squared f of s minus s f of, f of 0. Well, I mean y of 0, whatever. And then minus y prime of 0. Good. So these are the formulas to transform second-order differential equation using Laplace into frequency domain. And then the other formulas are for Laplace are given on the sheet, which includes
The one with the tau?
yeah, convolution, and involves the derivative one and the integral one that we did in class. They're all on the list of, if you look at the cover of the book.
You're not.
So as I mentioned, one of these will be missing on the list. And I think I mentioned that, where's the Thanksgiving? There it is.
Wow. Red and green? No, purple.
So these are the ones that you have to be able to compute by hand using the formula. I computed, so this is all posted. You can go look it up, whether it's a video or just the notes. So the requirement was to find the Laplace transform of e to the 3t. Well, if that was the question on the test, then your Laplace transform table, which is supplied, would have all of the formulas except e to the at. That one would be missing, right, on the list. And then you unleash the formula, do the whole thing. Convolution between two functions, t, e to the t, calculate, 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 integration by parts, a little bit of that, and there you go. At the bottom, we get convolution of two functions. This was something that I talked about. What happened here? I was explaining something, or maybe it disappeared. And then here is the one of the derivative problems. So we use the inverse Laplace and we put it together into the answer. So there are a few things that you can still review. Other than that, should be all, dare I say, straightforward. Anything else? I think we skipped that one.
If it's not on our exam, don't worry about it.
Oh, that's just that's just moving the terms. Okay, sure, we can take a look. Laplace, Laplace, Laplace. Since we are so late in with the scale, I can't remember which portions I skipped. I thought I skipped that part. So, translation. Translations means moving things left and right. But when you move things left and right in the frequency domain, what happens in the time domain, which is the t domain, is you are multiplying by e to the at. So, translation says that the Laplace transform of e to the at times f of t gives you f of s minus a. So that's the shift to the left and right, and the inverse Laplace of f of s minus a will give you e to the at times f of t. So these are the translation formulas. So translation is right here. So if you say that you have f of s minus 3, that means on the other end that you had e to the 3t times f of t. So that's technically all it is. Whatever you have here is the exponent of e. So frequency domain gets shifted to the right. So if you draw the graph for the frequency domain, it's shifted 3 units to the right, but the left-hand side, right, of the function, it actually got multiplied by e to the 3t in a time domain.
Those are on the chart, right?
Yes. That's on the chart. Now, you said you had a problem with the problem.
Well, just a question. So if we wanted to find the Laplace transform, or if we wanted to translate it,
You use whatever is easiest. Yeah. I don't, but we can do it. So,
Number four. It was a homework problem. Which section is it?
so f of t is equal to e to the negative t over 2 cosine 2 of t minus 1 over 8 pi, and we are supposed to just find the Laplace transform for something like this. Ready? Excited? No. So the first thing that we do, generally what I can do is I can write e to the at times f of t is, so that in a Laplace transform is going to give me f of s minus a. Now, when I compare these two terms, I find that a is equal to negative 1/2, which means that whatever the Laplace transform is for this puppy here, cosine 2, right, is going to be given as f of s plus 1/2. So every s that I am to write, I have to write it as s plus 1/2. Do we all get that?
No.
All right, from scratch.
Okay.
So now, we have the formula which states that if I have e to some exponent, at, times whatever function, it's going to be Laplace transform of that function, but needs to be shifted by a because we had it multiplied by e to the at. So now, by comparing these two terms, I notice that a is negative 1/2. If a is negative 1/2, that means when I plug in negative 1/2 on the right-hand side, minus and minus gives me plus, so I have f of s plus 1/2. So that means that all I need to focus on is transforming this part, and then whatever s I get, instead of writing s, I have to write s plus 1/2. Now, what do I have here? I have cosine 2t, right? Okay. So this can be, is this crazy really or no? No, it's not. Okay. So what should we do? What's the Laplace transform for this? Go to the chart. What happened?
No. It's a regular K, it's not the hyperbolic.
Yeah.
Regular K, right? So it's going to be cosine EAT cosine 2t.
Yes, so what do we get?
So the
So s
transform.
minus a over s minus a squared plus k squared.
Yeah, what happens to the negative 1 over 8 pi?
Can you distribute that over out? Isn't that a constant?
So what should we do? Identity? Yeah, but then you have the product over there. But you can't do Laplace transform the product, you have to involve convolution.
Was that like a prayer?
So what should we do with the t minus 1/8 pi?
Burn it. Just get rid of it. Erase it. Pretend it's not there. Actually, would it count as a constant? Alright. Well, no, it's a t, it's a variable, so
If I had the chart, I might be able to figure it out, but
you have the chart right here.
no, I don't have the. That textbook is on shit. So
It's the same stuff you're gonna get.
sorry, bro.
There's no
Okay.
no exchange.
Now, guys, this is a very spicy problem. So this will definitely not be on the test in this form, but you know we can have some fun with this and see what happens here. So now we understood the half and all of that business, but we have issue with this term here. So what I'm going to do is I'm going to use u substitution, right? And say u equals t minus 1/8 pi. Now, that fixes my issue with the cosine, which is now 2u, which you can regard as 2t. But it creates issues on the other side with the e now, right? So now e is going to be, so from here t is equal to u plus 1/8 pi. So now that becomes negative 1/2 times u plus 1/8 pi right there. Now when you distribute this, it becomes e to the negative 1/2 u minus pi over 16. And if you paid attention in algebra, this is e to the negative 1/2 u divided by e to the pi over 16, right? Because that minus, right, it splits into two e's, and then this one has a negative exponent, so you can kick it downstairs, times cosine 2u. So now, this u is just a time that is shifted. It's not a big deal, right? Now, what do we know about Laplace transforms? It's an integral. And if there is a constant, it gets kicked out in front of the integral. So the Laplace transform of this e to the negative 1/2 u over e to the pi over 16 cosine u is going to be equal to 1 over e to the pi over 16 times Laplace of e to the negative 1/2 u cosine 2u. Now we still see that our a for shifting is negative 1/2, and for our Laplace transform for cosine, we have that k is equal to 2. Yep. So we have 1 over e to the pi over 16. And now Laplace transform, we are ignoring the e part because that is just a shift.
So then cosine 2u.
So cosine 2u is s, but we have to use, instead of s, we have to use s plus 1/2 over s squared, which means s plus 1/2, everything squared, plus k squared, which is 4. So what's the Laplace transform? Laplace transform is equal to all of this.
Okay, just know that that won't be on the test. Wow. Okay. Still cool though.
Yeah, engineers used to have to do this, by the way, to do stuff. Today it's Mathematica, so.
I feel sorry for them. What was your,
Honestly, engineers deserve whatever they get.
Why? Your previous
Because there's so
session
many of them.
in
That's why.
Calc 2 where you thought I was looking at the U sub,
The dominating
Yeah.
obviously
Nice.
is STEM.
the section that you were doing in Calc 2,
Yeah.
U sub, how you show
Well, that's in Calc 1. U substitution is 5/5 in Calc 1.
5/5.
Yeah. So we did we did just a change of variable from t to u to make the cosine work better. This problem would be so crazier if you actually used the identity, which would, break these things apart, and then you would have to deal with sines and cosines.
Oh, that sounds fun.
So,
We can make it that easy.
I mean, let's see what, just real quick. If you have a cosine of 2t minus 1/8 pi, so that would be cosine of 2t minus 1/4 pi, or pi over 4. And then you unleash the formula, which is cosine of 2t, cosine of pi over 4, plus sine of 2t, sine of pi over 4. So now both cosine and sine, that's good, that's root 2 over 2. It's not that terrible.
That's supposed to what I do.
So cosine of, I'm out of cookies.
Well, you were telling me I couldn't do this.
Root 2 over 2 cosine, I lied, plus root 2 over 2 sine 2t, which is root 2 over 2 factored, and you have sine 2t plus cosine 2t plus cosine 2t. Okay, can be done this way too. That's fun. So, yeah, but my way was blue. So now you have the problem transformed. So Laplace transform of e to the negative 1/2 t times square root 2 over 2 kicks outside, sine 2t plus cosine 2t. Nice.
And you can use k s squared, but s squared plus 2.
So a is still positive 1/2, no, negative 1/2, which will make plus negative 1/2, and k, both k's are 2's. So now you have root 2 over 2 in front, and then Laplace transform, so that will give us the Laplace transform of sine 2t, which is just k over, so that will be 4 over s plus 1/2 squared plus 4, and then plus s plus 1/2 over s plus 1/2 squared plus 4. And then these puppies are the same, right? So we can add them. So we get root 2 over 2, 4 plus s, so that's s plus 9/2.
Yeah, no, that's 4.5.
Yeah.
Yeah, 4.5 right 9/2.
Oh, it's 2. Yes, it's k. Thank you. So it's 2. So that's 5/2.
Yeah.
Over s plus 1/2 squared plus 4. There we go.
Could you scroll just a hair? All right. Thank you. Cosine.
Because where did the 1 over 3 to the 5, 6,
Equivalent.
Wonderful. What does that mean?
Why not? What's e equal to?
What?
Is there a connection between e and sines and cosines? And you can compute that.
Oh, I heard.
Good.
Yeah.
So that was... Is there an easy way to see that?
So wait, square root of 2 over 2, how does that assimilate to pi over 15?
1 over pi over 16. Well, e and sines and cosines, they're related through the Euler's identity of e to the I pi, right?
Okay.
So you can work out with that one. You can work out also the identity that e to the x is equal to cosine cosine x plus e to the sine x. So there's that as well. So there are ways that you can make them compatible. Both ways are the same. Pandora.
He needs a second.
Oh, yeah, that was the one. All right, so what function, well, they're not all integration by parts, but most of them are. So which one should be transformed? What function? I think we did that in class. Did sine hyperbolic? We want sine.
What is he laughing about?
He just keeps saying tangent.
I think he wants a tangent one.
No.
So how about Laplace of sine 6t?
We'll be here all night.
Yeah, we'll be here all night. Oh, that's the spirit. That's the question, and then just bolt out.
Just leave. Yep.
Yeah. You deal with two integration by parts. All right, so we have the integral 0 to infinity of e to the negative st times sine 6t dt. Evan, shall we just turn this into complex and be done in 2 lines?
Please. I'd like to know that. I can remember 2 lines real easily.
Yeah, going back is not fun. All right, so what do we have over here? We have e to the negative st. So t is the variable that we worry about. So we set up our u as e to the negative st and our dv as sine 6t dt. So du is e to the negative st divided by, no, times, you're taking the derivative. So negative s, e negative st dt, and the v is going to be negative cosine 6t divided by 6.
Doesn't u have to be the trig function?
No, it doesn't matter. They're all cyclic.
They can make one harder if you do it.
It doesn't matter.
16.
So this now becomes negative 1 over 6 e to the negative st cosine 6t minus, because we have 3 minus signs on a pile, integral of s e negative st cosine 6t, and then if I kick the negative 1 6 in front of everything, then this becomes a plus. Good. So now we have another integration by parts. So we are going to say u equals se to the negative st, and the dv is equal to the cosine 6t dt. The du is equal to now negative s squared e to the negative st dt, and then v is equal to the sine of 6t over 6, and then the arrow. We still have negative 1 over 6 outside bracket. The first term leaves negative st cosine 6t, and then plus, and now we have all the other stuff. So se to the negative st plus, no, plus, yeah. And then there is 1 over 6 in front, and then there is a sine 6t, and then plus, because it's 1 minus 1 over 6 integral s squared e to the negative st sine 6t dt. Nice. Got it. Think.
We'll just leave it at that. It's called EFA.
No. Now we do algebra.
Sine 6t.
Yes, sine 6t dt. Like clearly, right?
So for test has this problem on it. That's just
So you did, yeah, you turn the page landscape, yes. So now we distribute this negative 1 over 6 in front. E to the negative 6t cosine 6t minus 1 over 36s. Well, we can say s over 36 e to the negative st sine 6t minus 1 over 36, and this is going to be now s squared over here, and then we can kick that in front of the integral, and then we have the integral, and then we have the e to the negative st sine 6t dt. Now all of this was equal, to integral e to the negative st sine 6t dt. So that means that we take this term here and we move it to the other side. So when that happens and you factor out this integral, you get 1 plus s squared over 36 C08 over e to the negative st sine 6t dt is equal to negative 1 over 6 e to the st. The pain goes away quickly.
how?
You just accept math.
I forgot
ST
all of this already.
sine 60. There we go.
This is not 2 lines. This is like 8.
Well, people want sine and it's fun. So now finally the integral, we can work this one out over here. So 36. So this will be 36 plus s squared over 36 if you work it out. So now the integral of e to the negative st, right, 0 to infinity, of sine 6t dt is equal to, this needs to go to the other side and flips and multiply everything, so it's 36 over 36 plus s squared, and then negative 1 over 6 e to the negative st cosine 60 minus s over 36 e to the negative st sine 60 computed from 0 to infinity. Nice.
Are we done yet?
Another.
No,
Is that sine?
So now we are supposed to plug in infinity. When you plug in infinity, both terms die, right?
Yep.
When you plug in infinity, because you have negative negative t, and you have negative t on both of these, those terms will go to 0, and the whole thing dies. Sines and cosines are bounded by negative 1 to 1, so there's no chance in L'Hopital rule switching this. So we are done there. Now the trick is when you plug in 0. When you plug in 0, so this negative becomes a positive now, so it's 1 over 6, and you plug in for t equals to 0, you get e to the 0 becomes 1, and you have 1, so it's just 1 over 6. And then plugging in 0 for t on the other side becomes 0 because sine of 0 is 0, so just get 1 over 6. So this becomes 6 over 36 plus s squared, or you can just look at the chart.
no. We clarified that. And we don't even know what it's like.
But we only have 2 projects?
Yes. There's no way we're going to do 4 projects in like 5 weeks.
There were supposed to be 4 projects?
But the syllabus also says like 8.
Is it differential equations?
Yes. I can relate
The
it
syllabus
to
also
the
says no profanity in class, but
Happy with your sine calculation?
why do you think Roadhouse has so much money? Keep putting money in the swear jar.
No, she didn't ask for sine. She said any. And then we have our. She's trying
Where's
to.
that voltage?
Oh, my question is for this one, could you just solve like the sine k? Like if you were given a sine of 6 to the negative possible, could you solve for sine of k to the negative of 6 or you want to find the way to all the
Isn't that the same? It's the same amount of work.
Well, I don't know, I just get confused sometimes.
Actually, if you solve it for k and then have to plug in 6 at the end, that's just one more step.
Well, like, I know I'll forget to put, like, you know, I don't know. I just know I'll mess something up with 6 somewhere.
Do it any way you want.
But, like, that's fun.
Yeah, sure. You could have asked that question without us working out this problem, but that's okay. Well, that's okay. Now you have t, you have t squared, you have sine hyperbolic. And you have e. So I think you have them all. Anything else?
Just these?
Differential equations, of course.
Yeah. 1 over
All of them.
Like all of these.
That sounds great.
Well, you know them already, so
You know
that's
he's not
fine.
going to give us.
I know like
He's probably going to give us either cosine kt, sine
That's good enough.
that's
cos
all I
or sine
know.
ht, or even ht cosine ht.
And then
Actually, you can get the other ones with the sine squared plus cosine squared by dividing them by dividing everything through
what
by
about sine
something.
8?
Did you just say that's so much work after actually seeing the power series problems and things?
Yeah, that wasn't that bad.
I just didn't know how to write the answer.
Can you scroll back to the part where it had the ones that could possibly be the ones?
Hey, you guys making study groups tomorrow?
I think it's 1, 2,
Do you guys do like study groups or anything for tomorrow or anything like that? Okay. When is what time? We usually post on the. I know, but by the time I get your post, it's already like a half hour later than what you guys posted.
It's posted. Oh, you want to put it on Snapchat? Oh, I see.
It actually is my camera gallery.
Alright, George.
Do you have
DM me
Snapchat?
tomorrow, right? For what? When we're going to take the test. Like when we're doing
It's
our
so
I know, but you're
I
responsible for
documented my
that.
whole
You're
chicken
responsible for me knowing this information.
and you